It is the largest flying object in history. A skyscraper built to escape gravity. We are not building one. We are building a fleet. A shipyard for the stars.
When the engines light, they generate 17 million pounds of thrust, enough to move a mountain.
But before it conquers Mars, it begins as a humble coil of stainless steel.
We don't use carbon fiber, we use steel. It is heavy, cheap, and can survive the hell of re-entry.
The steel is uncoiled and cut into precise lengths. These strips will become the body of the beast. Huge hydraulic rollers bend the flat steel into perfect circles. These are the rings.
Automated robots weld the vertical seam. The weld must hold cryogenic fuel at immense pressure. To build the tower, we stack the rings. One by one, the rocket grows taller.
Circumferential welding robots seal the rings together. It is a disco of sparks.
Inside, we install the domes. These bulkheads separate the liquid oxygen from the methane.
The domes are stamped from a single sheet to prevent leaking. They are the strongest part of the ship. Stringers are welded inside to stiffen the hull. Without them, the rocket would crumple like a soda can.
Now, the most complex piece of engineering on Earth, the Raptor engines.
The engine bell is not just a metal cone. It is composed of thousands of hollow channels.
Cryogenic fuel flows through these channels to cool the engine. Without this, the metal would melt in seconds.
The plumbing is a nightmare of complexity. High-pressure methane and oxygen lines woven together. At the center sits the turbopump. It spins at 20,000 RPM, pushing fuel faster than a fire hose. Robots assemble the engines in mass production. Rockets are now built like cars.
The booster requires 33 of these monsters. Installing them is a game of heavy metal Tetris.
Technicians connect the fuel lines. A single loose seal means an explosion on the pad. Near the top of the booster, we install the grid fins. These are the steering wheels for hypersonic re-entry.
Each fin is the size of a car and weighs 3 tons. They are cast from a single piece of steel.
Massive electric motors and batteries are installed to move these fins against the force of a hurricane.
Finally, the nose cone. Formed by stretching steel over a mold to create an aerodynamic point. One side of the ship faces the black cold of space. The other faces the inferno of re-entry, the duality of the machine. We cover the windward side in 8,000 unique hexagonal ceramic tiles.
These tiles are 90% air. You can hold a glowing red one in your hand without burning.
But they are fragile. A robot arm scans the hull and places each tile on 3 mounting pins. Humans must manually cut and fit the tiles around complex shapes like the flaps and nose.
The result is a suit of armor that can withstand 3,000 degrees Fahrenheit.
Now, the control surfaces. The massive forward and aft flaps are attached to the body.
These are not wings for flying. They are skydiver limbs for falling with style.
Powerful electric actuators are tested. The flaps slam open and shut with bone-crushing force.
The ship is rolled out to the launch site. It moves down the highway like a building on wheels.
The chopsticks arms on the launch tower prepare to catch and stack the vehicle.
The crane lifts the ship high into the air, placing it gently on top of the booster. The ship connects to the tower via the quick disconnect arm.
It is the lifeline. Before flight, we torture the metal. The cryogenic proof test.
The hull temperature drops to minus 300 degrees. Atmospheric moisture freezes instantly.
A visible frost line moves up the rocket, marking the fuel level inside.
The tank pressure is cranked up to the bursting point. If a weld is weak, it detonates now.
Past. Now, the real fuel. Liquid methane and liquid oxygen are pumped in by the ton.
The launch pad is not concrete. It is a steel plate protected by a massive water deluge system.
This water curtain must stop the rocket exhaust from melting the ground beneath it.
10 seconds to launch. The igniters fire. A shower of sparks under the engines.
The turbopumps spin up. The sound changes from a hiss to a deafening roar.
33 engines ignite. The force is equal to twice the thrust of the Saturn V. The hold-down clamps release. The skyscraper begins to fly.
As it climbs, the air gets thinner. The shock diamonds in the exhaust lengthen into a tail of fire.
We hit max Q, maximum aerodynamic pressure, the moment the rocket wants to tear itself apart.
The sky turns from blue to purple, then to the infinite black of space.
Stage separation. We don't just drop the booster. We blast it away with fire. Hot staging.
The massive booster falls away, flipping backwards to return to Earth. The ship lights its vacuum Raptor engines, giant nozzles designed for the void.
Internal fuel transfer is tested. Moving propellant in zero gravity is harder than it looks.
The payload door opens. A mouth swallowing the stars.
Mission complete. Now for the hardest part. Coming home alive.
The ship hits the upper atmosphere at Mach 25. The air cannot move out of the way fast enough. It compresses the air until it turns into plasma, hotter than the surface of the sun.
The black tiles glow cherry red. They are the only thing stopping the steel hull from vaporizing instantly.
The steel flaps act like rudders in this river of fire, steering the falling brick through the atmosphere.
It slows from hypersonic to subsonic in minutes. The plasma fades, replaced by twin sonic booms that shatter windows below.
The ship is falling horizontally. The belly flop. It looks like a building falling out of the sky.
500 feet above the ground, the engines relight. The landing flip, the most violent maneuver in aviation.
It fights gravity one last time, slowing to zero just as the landing legs touch the concrete pads.
It is not thrown away in the ocean. It is refueled. It flies again tomorrow. Rapid reusability.
We are not building one. We are building a fleet. A shipyard for the stars.
From a humble coil of stainless steel on Earth to the first human city on the Red Planet.
This is the gateway to humanity's multi-planetary future.